I arrived in White Sands in October 1945, and the first half year I actually lived at the White Sands Proving Ground proper. Only thereafter we moved to Fort Bliss, which is only about 50 miles away, and there's nothing in Texas.
No, of course not.
So it was commuting distance. Our first activity, when I say ours, I mean mine and that of the 120 associates from Peenemünde I was permitted to bring along to the United States, was to fire V2s in White Sands. The purpose of the exercise was twofold. One was that the Army wanted to know everything about the V2 and simply wanted to evaluate the V2 missile to learn all about it. The second was that these flights, which due to the limitations of the White Sand range had to be high-altitude flights, rather steep trajectories, were an ideal tool to do some high-altitude research. And so the United States Army invited a number of universities to participate in this effort to develop scientific payload packages that could be carried in the nose of V2s to conduct measurements about the nature of the very high atmosphere.
Yes, I remember I saw number 14, which had been instrumented by Princeton University. Number 14, I don't know whether you recall the number offhand, unfortunately did not go to a high altitude, but put itself horizontal about 700 feet up and cruised over our heads.
Some of them did it.
Which was very spectacular, I must say. It didn't do any good, but it was a beautiful picture. Well, but then, after the V2s were used up, I mean, the question then, which was discussed by everybody I know of, was should we, in the United States, build more V2s or go on to something different? And I understand that you yourself voted in the direction of going on to something different.
Yes, the V2, of course, by that time was an old workhorse, and it was certainly a good idea to start with a new concept and build an advanced missile, and rather than tooling up the V2 for production again.
Yes, and
Nevertheless, the V2 itself, of course, helped a great deal providing basic information for such advanced designs. For example, we built a two-stage vehicle consisting of a V2 as the first stage and the WEC Corporal as the second stage, which cracked the world altitude record in 1949 by reaching an altitude of 250 miles.
Yes, that was Project Bumper.
Yes.
Number 5 was the one that went to 250 miles, I think.
Yes, it wasn't the first bumper.
No, it was not the first. It was number 5.
Yes.
And then number 8 and 9, of course, have another historical significance. They were the first two missiles fired from Cape Canaveral.
That is right. They were fired into slanting trajectories. The purpose of these two flights was not to go after high altitudes, but to measure heat transfer at very high speeds when these vehicles, the second stage in particular, traveled through the atmosphere.
Yes.
And they produced some very valuable data, too. I would say, by and large, this whole V2 program in the United States was very gratifying for me, because in Germany, the V2, for all its potential as a scientific vehicle carrier, was, of course, used as a weapon only, the country being at war. And this period in the United States, where a total of, I think, over 60 V2s were fired, gave the V2 a chance of serving as a valuable scientific tool also, which had always been pretty close to our heart in all these years, but we never had a chance of...
Now some research could be done with the thing,
precisely.
And something fundamental could be learned.
Yes.
So then after the Bumper, the two-stage vehicle, the first, to my knowledge, first two-stage liquid fuel rocket, where both stages were liquid fuel.
Was the Bumper WEC.
Was the Bumper WEC.
V2 WEC Corporal combination, yes.
After that, the next one was which?
Well, as far as our group's concerned, we were transferred to Redstone Arsenal, Huntsville, Alabama, where we are now. That was in the spring of 1950. And simultaneously with this transfer, we got a new assignment, namely to develop the Redstone liquid fuel rocket.
Yes.
The Redstone, as you know, is now in the hands of the troops. Several units are deployed in Europe under the NATO organization. And this was the second operational liquid fuel rocket in this country. The first was the Corporal, which was an advanced WAC Corporal, but with a complete guidance system in it, and
an improved WAC Corporal.
Weaponized, as we say. It was transferred into a weapon which was never intended to be at the outset of the program.
No, because the WAC Corporal went the other way around. This was meant to be a high-altitude research rocket,
that is right,
and then turned into a weapon.
What happened was that when the Korean War broke out, and the country awoke to the fact that we couldn't lower our guards anymore because the Russians had not demilitarized their army when the war was over, a guided missile Tsar was appointed in the Department of Defense, and he took stock of what capabilities he had, and he decided the weaponization of the Corporal would be the fastest solution to give this country a long-range weapon, and the second logical step would be to have our group develop the Redstone.
Yes.
And this is how we got the assignment.
And now the Redstone is still of a range comparable to that of the V2.
Yes.
A few hundred miles.
It carries a lot more payload weight, however.
Well, it's much bigger. I can testify to that.
Yes.
But the next after that, then, is the Jupiter.
Yes.
Or was there anything in between?
No, we received the assignment to develop the Jupiter in 1955. Originally, it was supposed to be an Army 1,500-mile missile, but the operational use of that missile was later on turned over to the Air Force, but we continued the development nevertheless, and it's now being fielded by the Air Force.
Yes, and I found out that the public is confused between the Jupiter and the Jupiter C.
Well, that's a rather amusing story. In order to develop the Jupiter IRBM, the Jupiter 1,500-mile missile, efficiently, we had to solve the nose cone problem. That is, we had to come up with a design for the nose cone, or the envelope of the warhead, which would be capable of taking the severe aerodynamic heating during re-entry into the atmosphere. Now, there were two possibilities. Either we waited for the Jupiter missile itself to be available and used the Jupiter IRBM as a test carrier for its own nose cone. In this case, of course, any delays occurring in the nose cone development would have delayed the entire program. The other alternative would have been to come up with a temporary vehicle capable of also hurling some kind of a payload over 1,500 miles range, and use this temporary vehicle to develop the nose cone parallel to the development of the Jupiter rocket itself. And this temporary vehicle could be a Redstone, which we had in those days, plus a two-stage solid rocket cluster in the nose of a Redstone. This vehicle had a capability of not throwing a 3,000-pound payload over the full 1,500-mile range as the Jupiter could, but about 1/10 of that, namely 300 pounds. So you could make scale tests to develop the nose cone. Now, when we submitted this plan to the Department of Defense, we were told that this was fine and good, but the Jupiter enjoyed a higher priority than the Redstone, and I think they suspected us of sneaking the Redstone project into the Jupiter priority by proposing this. So they said, if you want to use some Redstones in support of the Jupiter program, you have to earmark those Redstones and give them somehow a Jupiter nomenclature so that we can identify them clearly and tell them from the rest of the Redstones which do not enjoy this priority. So we called it the Jupiter Composite Missile, and that's how the name Jupiter C came about.
I see there are not only engineering difficulties, but also legal fine points.
This is a case of political or legal engineering.
Yes, which have to be navigated through.
Yes.
But then the Jupiter C, of course, through the Explorer satellites.
Yes. This came about as follows. We had made several tests with this three-stage Jupiter C configuration in support of the Jupiter nose cone development program when the Sputniks appeared in the sky. And then, as you will remember, our answer to the Sputniks at that time was the Vanguard missile, which was a very advanced and highly sophisticated vehicle but was brand new at that time. It didn't have much testing on, and so to nobody's surprise, the early tests weren't completely successful.
Well, as a matter of fact, it is quite interesting that these preliminary so-called TVs, the test vehicles of the Vanguard, which were only one stage at a time, they all worked out nicely. But when the thing was put together, it stumbled over its own tail fins, which it doesn't have.
Well, this is usually what happens early in the program. And of course, when you work in a military missile program, you have the advantage that you don't have to advertise your failures so loudly as if you work in the glare of the
Yes.
Public limelight by firing satellites.
Yes, well, I think we both agree that the main thing that was wrong with the Vanguard is that it was much too new.
Precisely. As later flights have demonstrated, the Vanguard was entirely capable of doing what it was advertised to do. And you give the Vanguard another 20 or 30 flights, and it'll be a highly reliable vehicle, too.
Yes.
But you just can't force these things. It still takes 9 months to get a baby, and the same goes for guided missiles, too. Only it's not 9 months, but 3 to 4 years.
I was just going to say, only the gestation period is considerably longer.
Yes.
Well, now,
as a result of this, if I may hook on to your remark about satellites, as a result of the public pressure to put something up in orbit, the Department of Defense finally called us in and said, we understand your Jupiter C re-entry vehicles have a satellite capability if you replace a nose section by a fourth stage, and it can still orbit something like 20 to 30 pounds. So let's get going. And with all the previous work already being completed, we were actually able to fire this first thing into orbit within 84 days from the word go.
Yes, I know you referred to it as in 80 days around the world. And, well, now, since we are talking about satellites, we're beginning to get into the future. There have been all kinds of satellites up so far, all sizes, shapes, different fuels having been used. And it is, of course, absolutely no secret, and I saw it here, it is no secret to the extent that I saw it in your Redstone morning paper this morning when I arrived here at Huntsville, Alabama, that you are coming up with something super colossal called the Saturn.
Yes, the Saturn is our first big step into the real high thrust area. Our ICBMs, which of course are substantially larger and heavier than even our Jupiter IRBM, still have a total thrust of well under 500,000 pounds. Now the Saturn will have 1.5 million.
Yes.
It will be powered by 8 engines similar to those used in the Jupiter having, of course, only one of them.
Yes.
Each of these engines will even give a little more thrust than the one engine in the Jupiter. So with 8 of these engines, we have about 10 times more thrust as the Jupiter.
Mm-hmm. Coming out to about 1.5 million pounds.
1.5 million pounds, yes.
And then what is done with this depends, of course, entirely on what is put on top of this.
Yes. Now, we will put on top of it a Titan first stage. In other words, the whole ICBM, the whole first stage of the ICBM Titan.
Yes.
That's the second stage. And on top of that will sit a third stage, and if it's a high-speed deep space mission, maybe even a fourth stage.
If necessary, a fourth one.
That can be tailored to the needs of the customer, so to speak.
Yeah, yes.
In this respect, we're quite flexible.
Well, yes, and this is what I like about this idea, that you have here a very heavy, very powerful first stage which can carry almost anything desired, and it doesn't always have to be the same thing.
No.
With this ability to do almost anything the customer wants, what is the first objective?
Well, the very immediate objective of the Saturn project is to provide the transportation vehicle for a global communication system. Specifically, we are to fire 3 satellites into a 24-hour orbit in the equatorial plane. A 24-hour orbit is an orbit with an altitude of approximately 19,000 nautical miles above the surface of the Earth.
Yes.
if in the equatorial plane you fire such a satellite in the west to east direction, then the satellite will come to a standstill over a certain point of the equator. The Earth rotates about its axis also once in 24 hours. So if the satellite's period of revolution is 24 hours, it will be a relative standstill over a distinct point on Earth.
Over a point on the equator.
Now, if you put 3 such satellites into the same orbit, all 24-hour orbits, all in the equatorial plane, and you space these 3 satellites 120 degrees apart in their orbit, then at this distance from the Earth, each of these satellites will be able to see the 2 others in an optical line of sight. At the same time, these satellites will be in permanent line of sight contact with a tremendous area on the globe. And in fact, there will be no point on Earth that is not in direct line of sight contact with at least one of them.
Yes.
That means if you want to make a telephone call, say, from New York to Paris, then one satellite may be in simultaneous line of sight contact with both New York and Paris, and you just send your radio message, your telephone, up to the satellite, and the satellite beams it back down onto Paris, and you speak in direct line of sight contact.
Yes.
With the satellite working as a kind of a repeater station.
Yes.
If you want to telephone, say, from San Francisco with Paris, where you may be too far away to see the same satellite, then San Francisco beams its message up to the satellite in line of sight contact from San Francisco.
The one they
that
can
satellite,
see.
Yes. That satellite beams it over to the other satellite that can be seen from Paris, and that satellite beams down to Paris. The advantage of this scheme is the following. There is no real difficulty in providing communications on the same continent. For example, if you want a telephone from New York to San Francisco, you can use the wires. And
pick up the phone
and you can even use multiple channel telephone with carrier frequencies over the wire, and there are lots of connections. So there's no real problem in providing more traffic, more service for more telephone traffic. The moment you have to cross oceans, the situation is quite difficult and different. Either you have to put cables in the water, which is a very costly thing, and gives you only a few leads anyway, or you depend on low-frequency radio transmission, unless you want to go to ionospheric scatter radio, which is utterly unreliable.
Yes.
Now, that low-frequency radio communication presents you with the problem that the frequency spectrum is very limited. And even with all the tricks at our disposal today, such as single sideband reception, suppressed carriers, and so forth, we simply cannot accommodate more traffic on that limited spectrum.
Yes.
But you are depending on these waves because they are the only ones who follow the curvature of the Earth. If you want to go to short waves and microwaves, you are limited by the fact that these waves, like light, propagate only along straight lines, and they do not follow the curvature of the Earth. But the frequency spectrum in that area is virtually unlimited because you can put a lot of frequencies very close together without interference. So you can, by establishing a communications satellite system where you beam messages up to the satellite and the satellite beams it back down to another point on the Earth, you can expand our present transoceanic telephone connections 100-fold or 1,000-fold without any great difficulties.
Yes, this scheme, of course, has been talked about in circles of space travel enthusiasts and rocket engineers for some time, but you say that this is actually the first use to which the Saturn will be put.
Now an established program, and all the money we are getting for the Saturn comes out of this kitty. In other words, we are getting it for the specific purpose of providing this country with such a communication satellite system.
This, of course, is completely unmanned. This is a fully automatic system.
Yes, it will be a fully automatic system, but it's quite conceivable that as the need for more traffic increases, say if the television networks wants to pick up the idea and say, now we want to provide global television service with that same system, it may well be that the units going around there in that 24-hour orbit will become bigger and bigger, and finally you will You may even want to have a maintenance crew up there. That's how people may still get into the act.
You mean simply by enlargement, and then at one time they get to be too large and too complicated to be completely trustworthy?
Well,
without maintenance?
I wouldn't put it this way. Suppose you have either 3 very large communication satellites up there or a great number of little ones, then you may reach a point where it may pay off to repair and maintain these things by sending manned repair crews out there, or even having people live there more or less permanently to keep these things in shape.
Yes.
And a vehicle like the Saturn, of course, can not only carry dead equipment up there, but it can very definitely also send manned capsules up there with repair crews that would be capable of returning to the Earth again. I think when we talk about manned space flight, the first attempt in this direction, the first serious attempt, will be the so-called Project Mercury, which is a program supported and financed and sponsored by the National Space Administration. Under program Mercury, it is planned to fire a manned capsule with an Atlas vehicle into a low orbit and let the capsule pilot go around the Earth several times, and then with the help of a retardation maneuver, this nose cone will slip back into the atmosphere, will be retarded by aerodynamic drag, and finally land in the water, where it will be where it will be fished out of the water like our Jupiter nose cones with the monkeys aboard.
Yes.
This will definitely be man's first step into an orbit, and from there on, it doesn't take much imagination to see that with a big booster like the Saturn at the bottom of such a vehicle, you need not limit this to one man, but you can send a whole busload of people up into an orbit.
Yes, and what I mainly meant to point out was this, that the space station, as it has been discussed before, which has as its main job the observation of the Earth, will be in a rather low orbit, while the communications satellites, the telephone satellites, let's call them, have to be some 22,000 miles away.
Yes, actually, there is a question of whether it is realistic to talk about just one space station. It depends very much on what the purpose of such a station is. Shall we say, the choice of the orbit of a space station depends very much on its purpose.
Yes.
For example, if you want to use a space station to maintain a continuous surveillance of the weather development on Earth, then it is very important to put these such a satellite, such a space station, into a very into a near polar orbit, so that you can see the weather developments over the polar areas also.
Yeah. Yes, it would also have an orbit differently located, so to speak, with respect to the Earth. The telephone satellites would be over the equator.
That is right.
While this one should go over the poles or very near the poles.
Yes.
But what I've said first is that it also would be much nearer to the ground.
Yes, I think both is correct. My point is, I think there may be several satellites for several applications. There may be manned space stations for in connection with the communication satellite project in the future, and there may be lower space stations going over polar orbits
which
for weather observation, and there may be others in between.
Earth Watch, polar orbit replaced the iceberg patrol at the same time.
Yes.
Weather reporting, even... what might
or
be...
for military observational purposes, you want to have highly inclined orbits
yes.
too, so you can
yes.
cover the northern and the southern hemispheres.
And they could take in what might be called accident reporting. That's,
yes.
for example, a wrecked ship or things
yes.
like this.
Yes.
They could report
yes.
on that. Now, these would go very nearly over the poles, if not over the poles, and would be quite close. Then... is there any reason for having something at an intermediate distance? Let's say if this Earth Watch satellite, as I like to call it, is in a 400-mile orbit.
Well, I think we have to watch the Van Allen belt.
Yes, we sure do.
The Van Allen belt begins at an altitude of approximately 700 miles and stretches out to altitudes very close to those envisioned for the communication satellite.
Yes.
Whereas it doesn't seem to be too difficult to penetrate the Van Allen belt in a fast departure, say, to the moon or the planets, where your stay time in the Van Allen belt will be quite limited. There seems to be a major problem of leaving a permanent manned space station right in the Van Allen belt. You would have to provide so much shielding that the weight penalty is so high.
At the moment, it does not look impossible, but it certainly looks impracticable.
Yes, in other words, the way it looks today is you stay below it, which means below 700 miles approximately, or you just go much further
beyond
out.
20,000.
Unless you have very good reasons to build a well-shielded space station right within the Van Allen belt, it is just not too attractive.
No, it's a little bit like the speed of sound. At 0.8 of the speed of sound, everything is fine. At 1.2, everything is fine again, but not in between.
Only the belt is a lot wider.
It's a lot wider. Well, the only reason I could see for a heavily shielded station in the belt would be one designed to observe the belt itself. And I think that could be done without a manned station.
Yes, actually, the human body has no sensors to give you any of the information you want. What we would like to find out right now, for example, is what is the percentage of protons and electrons in this belt, what is their energy spectrum and so forth. Now, the human body has no...
Which the human observer couldn't do anyway.
Organs. You may be able to kill a man in that belt, but he still wouldn't know what exactly killed him. So you need instrumentation to give you this kind of information, and there's no reason why this cannot be radioed down to the ground from an unmanned satellite.
With reference to the first man in orbit, the flight of the astronaut, will he be carried into orbit by an Atlas missile, so to speak, cold, or will he have previous experience on a smaller scale?
That's a good question. The National Space Administration has actually called us here at Huntsville in to provide some hardware for the initial training flights of these astronauts. The plan is to put the man right from the beginning into the ultimate capsule, which will later on be used for the orbital flights with Atlases. But his first flights will be conducted from the nose of a Redstone vehicle only over a range of approximately 150 to 200 miles. In this fashion, we will give him a 6-minute ride through the zero-gravity condition and a typical re-entry with ensuing parachute landing and being fished out of the water.
In short, the nose cone ride in a Redstone will provide him more or less with the experience, except that the zero-G period, which he would spend in orbit, has been trimmed from...
Pretty good feeling of what he will be up against when he finally boards that Atlas.
Will they all get since it is not certain, and I understand it will not be certain until fairly much the last moment which one actually goes into orbit, will they all get such a nose cone ride?
I think this is to be expected, yes. We are furnishing several Redstone vehicles, and it's, of course, entirely up to the NASA, to the National Aeronautics and Space Administration, to decide who will take the first ride.
Yes, but I mean, they will have had several people who had the nose cone ride in preparation for the orbital flight.
Yes, you see, this is necessary, to have several test pilots standing by, because you have to be in perfect physical conditions for these early tests, and it can always be that a man catches a cold and everything else has been prepared, the ships are in position, and the man wakes up with a head cold and doesn't qualify that day. In this case, the number 2 man will be slipped in.
Now, in talking about the investigation of the Van Allen layer, which is a most interesting, if unexpected item that we didn't know about a few years ago, you said that for this particular observation, instruments are far superior to men because men happens to lack the organ which could make the determination, which could make the discoveries, if you want, that the instruments can. This, of course, brings up the general question of when is man needed in space? Where does he have to step in because his instruments now don't do the job anymore?
Well, I think very fundamentally, the instrumentation has its limits. You can design instrumentation for a known objective. You have to specify in advance what information you seek and then build your instrumentation accordingly so that it furnishes you with the answers.
So you have to know what to look for in order to ask intelligent questions via the instrument
Precisely.
design.
And so, as I see it, man is necessary wherever you are confronted with a great unknown, where you just don't know what to look for and where you expect the unexpected, against which you cannot design any machinery. Just to illustrate my point, suppose we were living on another star and wanted to find out what kind of life exists in the Brazilian jungles. And you would have to build a telemeter package to furnish you all the answers about snakes and birds and crocodiles, but also bacteria
and insects.
And
do these insects
and everything,
eat other insects or plants?
And the question of contagious diseases and what have you in the Brazilian jungles. You'd be confronted with a rather formidable problem, because not knowing what to expect, you couldn't design this machinery to meet all your objectives, and as a result, the old-fashioned method of the Spanish explorers, but just sending a man there for a look-see, is still the most effective.
Yes, and of course now we would see to it that this man is well protected, or as well protected as we can make it, but it is then inherently the higher versatility of the brain over the instrument which counts.
Wherever you need judgment, wherever you need coordination of several apparently irrelevant and disconnected pieces of information, and put a story together out of a number of apparently independent inputs, the human brain still cannot be beat.
Cannot be beat, no, and won't be for a long time.
No, I think never will.
Now this gets us to the next topic. We can penetrate the Van Allen there. We can go out farther into space. Where will we go first?
Well, I think in the area of deep space penetration, the most logical step after manned orbital flight and safe return from orbital flight has been obtained and demonstrated. We will probably expect to send a few men around the moon on a long-stretched flight path behind the unknown far side of the moon, and return them back into the Earth atmosphere with an ensuing aerodynamic deceleration and landing. Now, such a flight would not include a landing on the surface of the moon. No. It would be essentially a high-speed power maneuver on the outbound leg to get us that far out, and then as the rocket comes almost to a standstill behind the moon would sweep through between rocket and Earth, and then it would fall back towards the Earth under the gravitational pull of the Earth and would tangentially sweep into the Earth atmosphere and land.
Yes, so the first deep space trip for people is still, as we said many years ago, the
trip
flight around
the
moon without landing.
Yes.
Then, of course, when it comes to the neighboring planets, we have this nice toss-up that we know nothing about Venus at the moment, so this makes it more interesting, but we don't know what to protect against, while Mars doesn't look very hospitable, but at least we know a lot about it.
Yes. Well, as far as flights to Venus and Mars is concerned, the difficulties are about equal. It is a little closer to Venus to get there than to Mars, but Venus has a stronger gravitational field of her own, so it takes a little more velocity to put a rocket, say, into orbit around Venus than it would cost to put it in orbit around Mars.
Yes.
So it's about equal.
Yes, in spite of the somewhat greater distance to Mars, the engineering problem is very much the same, and the fuel problem is likely to be very much the same.
And as you just said, in the case of Mars, due to the fact that the atmosphere is transparent, we know a little better how to equip our machinery, how to build our automatic instrumentation to give us more information on Mars.
Yes, we know what questions to ask.
For example, photographing Mars' surface from an orbit around Mars would be a very interesting thing, and we would know right now how to design such equipment. We could entirely envision televising such pictures back to the Earth and give us some answers to such riddles as, do the marching canals really exist?
Are they canals?
Are they canals,
are they?
or what are they? Whereas in the case of Venus, it would probably be necessary to send a kind of a glide bomb into the Venus atmosphere with television equipment and see whether that thing ever comes out of the Venus atmosphere and take some pictures on what's underneath, or whether it'll crash in the ground without telling us anything, thus indicating that the clouds go all the way down to the ground.
Yes, in other words, we do know enough about Mars to design equipment. In the case of Venus, we first would have to gather experience.
Yes.
We would have to almost engineer a number of failures in order to know how to avoid them.
Yes, yes.
And then, of course, manned flight to these neighboring planets would follow these unmanned probes, which have given the final information.
Yes, I think to the planets we should expect unmanned probes first, maybe even one-way probes that just go out to the planet, either pass those planets in a close pass or go in orbit around these planets and televise their information and telemeter their information back to the Earth.
Yes. And man, of course, will follow, as man always has.
Yes.
And now we come to a semi-philosophical question. What right does man have in space?
Well, it has been stated that we don't belong there because outer space is a realm of God and we better stay on this Earth. I don't like the implication of these statements because it could be construed as to mean that the Earth itself does not belong to the realm of God.
If you permit me to interrupt you, this is precisely the answer I gave once at a meeting where somebody came up with this question. I said, and now, in other words, the Lord is not present here.
Well, this is the way I feel
about it. A very red
it.
face and a silent withdrawal. So this reasoning, of course, is primitive and nonsense.
Yes. I think if the Lord didn't want us to go into outer space, he would simply deny us the means of doing it, and the fact that he seems to support our projects and allows us to demonstrate that we can...
we do have the brains. Our bodies are built better for high accelerations than the bodies of any other animals except our relatives, the primates. So it looks very much, if the term can be used here in this connection, like something preordained.
Precisely.
But I wanted to bring this up because that question does come up every once in a while, mostly from laymen, I mean now in the theological sense, because the theologians who have been thinking about this problem for about as long as we have been talking about the engineering problems are, of course, convinced that there is no obstacle from where they sit.
Well, the Pope himself has blessed the idea of flight into outer space during the meeting of the International Astronautical Federation in Rome in 1957, I believe, or was it 56?
No, 57.
57, and he stated very plainly that God has in no way limited man to this planet, and that the Catholic Church saw no objections whatsoever to this endeavor of exploring other worlds.
I read his statement both in the original French and the English translation. That's why I said the theologians, of course, who have been thinking about this will not voice this objection. It comes only from circles of laymen.
I think it is a great tragedy that so many people still believe that religion and science are not compatible, and it's in a way a fundamental struggle on between what you might call search for faith and search for truth. I think with every new mystery that science has solved, it has also discovered at least 3 new questions which science hasn't solved yet.
Yes.
And I think the closer we get to the facts and the more we learn about the mysteries of nature, the more we learn to adore and to just become more humble in our outlook.
Yes, and this is bound to happen. I have a quotation there from the French philosopher Pascal, which I love, and which I have used before on occasion, where Pascal said that knowledge can be compared to an expanding sphere. The larger it grows, the more points of it will touch the unknown.
Yes.
That is precisely the same you just said before.
Yes.
As our knowledge expands, and this time the word is to be taken literally, one day we will run into other life forms. And this, of course, is the second most favorite question that always comes up after every lecture about other life elsewhere.
Well, I think there's enough evidence today that at least some low forms of life exist on Mars.
Yes, that can be accepted as
we know that
established.
Whenever the snow melts on the northern or the southern polar cap of Mars and humidity reaches the moderate latitudes, that vegetation seems to spring into life, and large areas of Mars are covered by a bluish and greenish hue. In fall, on that particular hemisphere of Mars, this vegetation seems to wither, and these seasonal effects appear during every Martian year.
They come up every year, and there is one other little item which is very interesting. You said that the vegetation is bluish-green or greenish-blue. Well, a Russian astronomer by the name of Tikhov has been looking around on Earth for equivalent color values in vegetation, and he found them strangely enough in the North Siberian forests. And then he made additional measurements which gave the result that a forest in the temperate zone will radiate or reflect about 25% of the infrared of the heat rays that hit the leaves. The North Siberian forest cannot afford this. It does not reflect more than about 2% of the infrared rays. And the Martian plants have the same color value. They, of course, since Mars is farther from the sun, also cannot afford to waste any infrared that may strike them.
Mm-hmm.
So we are pretty certain about life on Mars, at least vegetation. But when the public asks this question, they always have something more than plant life in mind. They are not even interested just in the neighboring planets. They mean, well, they say the universe, they mean the galaxy as a whole.
Well, I have no doubt whatsoever that in the vast depths of the universe, there will not be just a few hundred, but probably millions of planets capable of supporting even higher forms of life. And I wouldn't be a bit surprised if there are some planets among them that are capable of supporting even a much higher form of life than this Earth. In other words, that there are intelligent beings around somewhere who, for whom we with all our intelligence would be no match.
Well, of course, this is the same way I feel about it. And I think the most interesting moment in history that could happen is if two such cultures meet.
Yes, it certainly would. Whether we'll ever be able to visit such a planet remains to be seen, but in 25 years of work in the missile and space field, I've always found out that whenever I use the word impossible, I ultimately wind up with the losing end.
You ultimately wind up building it.
Yes, building it.